Go ahead and draw these on the back of 10.3 notes. Each of these asks us to find the measure of a certain arc. The first one says AC. What do we know already about arc AC? It's what? It's minor. Right, correct. What else do we know about this arc? It's congruent to CB. So, here's what we can do. Do we know any of the arcs inside of the circle? We know one of them, right? Which one do we know? AB. How many degrees is it? 90 degrees. So how can I figure out how much is left if I already have 90 degrees? Subtract it. We're going to do that first, which makes 270. So that means the rest of the circle combines to 270 degrees. It combines from these two congruent arcs, so we do split it evenly between the two of them. We divide by 2, and that makes 135, and AC is 135. On the second, we got a similar idea, except for we have a diameter, right? What does the diameter do to the circle? Splits it in half. So I know the bottom half is how many degrees? 180. And the top half, adds up to 180 degrees. Okay, but we're finding something specific. We want to find DAB. We already know from D to A is 180. We need to find out how many degrees AB is. Okay, so there are a couple ways to do it. I think the easiest way is to know the top portion is a semicircle. It is 180 degrees. How much of the 180 in the top do we already have? We got 90 of it. So subtract 90. How much remains for the other two arcs? 90. And what do I know about the two remaining arcs? They're congruent. So what can I do with that 90? Divide by 2, which makes each of them 45 and 45. So when I go to find DAB, what can I do with my 180 and the 45? Add them. 180 and 45 make 225. Good. And then whenever you're ready, we're ready for the notes. That was just review. We're going to be talking about using chords. So let's back it up and refresh on some vocabulary. What do we call a segment that goes from the center of the circle to the edge of the circle? A radius. What do we call a segment that goes edge to edge through the center? Diameter. What do we call one that just goes edge to edge? A chord. A diameter is a type of chord. So we're going to be talking about chords, also some diameters in this section. So I'm going to have you highlight in a second. In the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So here's what you're going to highlight. In the same circle or congruent circles, arcs are congruent if their chords are congruent. Okay, so we're going to apply that to this picture here. All right, so here's what it's saying. If these two chords are in the same circle, we're talking about A, B, and C, D, they're congruent, which means that they are the same length. So if AB is 3, that means CD is also 3. It means that the arcs that the chords create, so AB cuts the circle and forms this arc. And CD cuts the circle and forms this arc. Because the chords are the same length, the arcs will be the same measure. So that means give me a degree, any degree number. 46. Sorry. If AB was 46 degrees, that means CD would also be 46 degrees. The arc will be congruent to the arc, the chord congruent to the chord. Okay, so we are going to practice it here. It's to the right of the property on your page. In the diagram, circle P is congruent to circle Q. It's very important because they either need to be the same circle or congruent circles. So we've got some congruent circles. We know FG is congruent to JK. And then we know the measure of JK is 80 degrees. So we want to find the measure of FG. FG is formed by this chord, chord FG. What do we know about chord FG? It's congruent to JK. So if the chords are congruent, that means their arcs are congruent. So what is the measure of arc FG? 80. Okay, that's the first one. The second property, again, you're going to highlight what I tell you. If a diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. So highlight, you've got a diameter, and it is perpendicular to a chord. That means the diameter bisects the chord and its arc. What does perpendicular mean to me? Intersect and form 90. How do I know that in this picture, that my diameter intersected and formed 90? Yeah, there's a right angle. Here's my diameter. Here's my chord. They intersect, form 90. That means the diameter bisects. What does bisect mean to me? Cuts in half. The diameter cuts the chord. So the chord is FD. That means the chord is cut in half. And that means the arc that the chord forms is also cut in half. So if you want to mark it like this, it's helpful for later on. The most common mistake that students make is that they think that this arc forms 180, and it doesn't, because this does not start and stop. FD does not start and stop on the diameter. So it's not 180, it's going to be less than that. So we're going to use our property here with this question. Which of these segments is the diameter? JL, and that means the chord is HK. So the diameter and the chord, they form 90, which means the chord has been cut in half. So we'll start there, HK. We want the full length of the chord. Is 7 the whole length, or is 7 NK? It's NK. It's from N to K. So what is the full length of HK? 14. Find the measure of arc HK. So finding the measure of the arc. Again, the diameter, which I highlighted, it also, because it's perpendicular, it also cuts the arc in half. So the two portions of the arc are congruent to each other. So what can we do with those two things? Set them equal. So 11x will equal 70 plus x. Subtract x. 10x equals 70. Divide by 10. And x equals 7. Did it ask for x? No. So what do we need to do with x? Plug it in. Where would we like to plug it in? 70 plus x, that's fine. So instead of x, we're going to say 7. Yes, ma'am. So we found JK, but I want to find HK. So what do we know about HJ? What's the measure of HJ? Yeah, 11 times 7, which is also 77. So what can I do to find the full measure of HK? Yeah, 77 plus 77, or 77 times 2. Either way, what number do we get? 154. Yes? No? Okay. All right, so now we just practice it. Find the measure of the arc or the chord. I do find it easiest to fill in all the angles that we know before we start. What is the only angle we're given? 42. So This angle is up here. It just is a bigger font, so it doesn't fit higher up. So if this is 42, what other angle do we know right off the bat? The one right above it, the vertical angle. How many degrees is it going to be? 42. We can also find the angles right next door. What relationship do these two angles have? They're supplementary. They're linear pair, right? So I'm going to take 180, subtract 42, and I will get 138, which means both of them are 138. Okay, I wrote small so that I don't know, lots going on. Okay, we'll see why this matters. We're going to first find arc WX. So WX, remember that every arc corresponds with its central angle. So the central angle starts and stops on the arc. So what is the central angle for WX? 42. So it's going to be 42 degrees.
An arc is degrees, right? Like
Yes, ma'am. Always going to be degrees. In chapter 11, we're going to go over arc length, but it will literally be called arc length, where it would literally be in inches or centimeters or whatever.
Okay.
But in this section, it's always degrees. YZ is a chord. So YZ, you can probably figure out just from, common sense. What do we think YZ is? 3.6. But I will explain why it is. I highlighted them both in blue, but both of these chords are formed by the arcs, right? These two arcs are congruent because their central angles are congruent. So that means the chords that are formed by those arcs are also congruent. WZ is going to be 9.2. And it's for the same reason. WZ was formed by this arc, and XY is formed by this arc. And these arcs are congruent because what are their central angles measures? 138. Yeah, they're both 138 and 138. Okay, which brings me to the next question. The measure of XY, which is this one, 138. Because its central angle is 138 degrees. All right, now we do two more together. Find the value of x. So we see that we have the diameter is intersecting a chord and they form 90. So then what do I know has happened to the chord? It's been bisected. So we're going to set them equal. So 2x minus 4.1 equals x minus 0.5. Subtract x. 2x minus x is x. You should be able to subtract and add a decimal without a calculator, especially if you're planning on taking the per test. We're going to add 4.1. In order to subtract these, in order to do it on paper, and even in your calculator, the bigger number needs to be in the top and the smaller number needs to be on the bottom when you subtract. So ignore the decimals for a second. What is 41 minus 5? 36. And then you just drop the decimal where it lands. So x equals 3.6. The last one, again, we got a diameter and a chord are perpendicular. So the chord was cut in half. 2x plus 1 will equal 3x minus 5. Subtract 2x. 1 equals x minus 5. Add 5 and x equals 6. The only difference you might see on a quiz or a test is that it might ask you for the length. So just be prepared. If it says find the length of PR, you would plug it in and then find from there. Okay, but here it just said find x. These next 4 you're actually going to do on your own. But before you do, I need you to understand that these are 2 separate questions just using the same picture. So on number 1, when it says the measure of AB is 110, that is not the answer to number 2. They're using the same picture. They're 2 separate problems. Okay? I'll walk around and check them.